both are clear.
Hello.
Okay, sound and spin both. Point 0.5 is your answer. Get it? How many Faradays? 0.2 mole. So for the 2 mole, that's 1 mole of the calcium. So Ca2 plus 2 electron to use the calcium. So for 1 mole calcium, 2 mole electron is required. So point of 0.2 mole, 0.25 mole. So how much required? Okay, this is required as a 0.5 mole, 0.5 Faraday. The number of moles of electron pass when current of 2 ampere. So this is current I is equal to 2 ampere pass through 20 minutes. So T is equal to 20 minutes. So 20 multiplied by 60 is equal, that's the seconds. So number of moles of electrons. So first we have to calculate the coulombs. So what is the coulombs? So coulombs is equal to, so what is the number of moles of electron? Number of moles of electrons is equal to current in ampere into time in seconds, this whole divided by 96500 coulombs. So substitute the value, we'll get the answer. So what is the current in ampere? 2 into time in second, how much? 20 multiplied by 60, this whole divided by 96500 coulombs. We'll get the answer 2.487 into 10 to power minus 2. 2.487 into 10 to power minus 2. Next, that's a two electrolytic cell are connected in a series containing copper sulfate and molten AlCO3. So 0.4 mole of copper are deposited on cathode of first cell. The number of moles of aluminum deposited at cathode cell. So this is the number of moles of the aluminum deposited. Number of moles of aluminum deposited divided by number of moles of the copper deposited is equal to that's a mole ratio of the aluminum. So what is the mole ratio of aluminum? Mole ratio of aluminum is 1 by 3. Mole ratio of copper is equal to 1 by 2. Mole ratio aluminum 1 by 3, copper 1 by 2. So this is 2 by 3 actually. This is 2 by 3. So what is the aluminum? So number of moles of aluminum deposited. So number of moles of aluminum deposited is equal to 2 by 3 multiplied by the number of moles of copper deposited. So what is the copper deposited? 0.4. So this is 0.4. So that's is equal to 0.8. 0.8 divided by 3 will get the answer 0.27. 0.27 mole of aluminum deposited. The first take as a mole ratio. Mole ratio 1 by 3, aluminum 1 by 3 and copper 1 by 2. What happened when ionic hydride? Ionic hydrides of S block element in molten state is electrolyzed. The ionic hydride, for example, sodium hydride. This is Na plus H minus. So dihydrogen is liberated at anode. Dihydrogen म्हणजे hydrogen gas. Hydrogen gas is liberated at the anode. Okay, due to oxidation. Next, which of the following is correct for electrolysis of brine solution? Brine is the aqueous NaCl. So at the aqueous NaCl, hydrogen gas is liberated at the cathode. In the electrolysis of aqueous NaCl, so aqueous sodium chloride, at the cathode and anode, chlorine gas at anode and cathode, at the cathode there is a hydrogen gas, aqueous NaCl, and this is for molten NaCl. Chlorine and Na, molten NaCl, this is for molten sodium chloride. The SI unit of electrochemical equivalent, kilogram per coulomb. Electrochemical equivalent, kilogram per coulomb. Mass divided by charge. What is the time required to deposit 1 millimole? 1 millimole 10 to power minus 3 mole of aluminum by passage of current. So this is current and this is the through aqueous solution. So what is the time required? So the time required, millimole of aluminum. So moles of aluminum is equal to, okay, that's current in ampere divided by the time in seconds. So for the current in ampere multiply by time in second, and this whole divided by 96500 coulombs. So what is the number of moles of aluminum? So number of moles of aluminum is the 10 to power 3. So this is 10 to power minus 3 is equal to current in ampere 9.65 multiply by time in seconds, and this whole divided by 96500 coulomb. Then if you solve this, you will get the answer 30 seconds. T is equal to, तो ह्या फॉर्म्युला मधून टी कॅल्क्युलेट करा. तर सो टी इज इक्वल टू हाऊ मच? 96500 multiply by 10 to power minus 3 and this whole divided by 9.65. So is equal to 30 seconds. So 30 seconds. T. ओके एम्पियर आहे आणि देन आय थिंक मला असं ठीक आहे 1 मिनिट फक्त थांबा. सॉल्व करा बरं प्लीज हे लवकर. सो पॉईंट शिफ्ट करून घ्या याच्यामध्ये. 0 0 गेट कॅन्सल आणि पॉईंट शिफ्ट करून घ्या. 6 1 2 3 1 this is 1 this is 1 2 and 3. So 96.5 and this divided by 9.65. So 10 second answer आहे. 10 second. प्लीज चेक करा बरं. 10 second answer आहे. 10 second answer आहे याचा answer आहे ना 10 seconds. ओके चेक करा प्लीज. During electrolysis of aqueous NaCl, the product obtained at cathode, hydrogen gas at the cathode. In 2 hours, certain current liberates. So this is the time 2 hours. So this is the 2 into 60 into 60 seconds. So 2 into 60 into 60 seconds. Next, this is the gram actually. This is the gram of hydrogen, W. How many grams of copper be deposited by same current passing flowing for same time copper sulfate? Molar mass copper दिलेला आहे. So how to calculate? So this is calculated by using the same current है 2 times hour है. So this is the that's the mass or the weight of the copper deposited, weight of hydrogen deposited divided by the weight of the copper deposited is equal to the mole ratio. So what is the mole ratio actually? So mole ratio of the copper. So what is the mole ratio of hydrogen? 1 by 1. This is whole divided by 1 by 2 and multiply by, so this is the 2 gram, hydrogen as a 2 gram and this is copper as a divided by copper 63.5. Okay, so during the electrolysis of aqueous sodium chloride, the product obtained at anode is chlorine. Product obtained at anode is chlorine gas. So chlorine at the anode. So this is the anode at anode. How much charge in coulomb is required for the reduction of 1 mole Al3 plus to Al? So okay, Al3 plus plus 3 electron to gives the Al. So this is 3 mole. So this is what is the 3 mole? So 3 mole is equal to 3 Faraday and 3 Faraday is equal to 3 multiplied by 96500 coulombs. So this is your answer, coulombs. Okay, 3 into 10 to, okay, 3 into 96500 coulomb. 3 multiplied by 96500 coulombs. Answer 2.895 into 10 to power 5. How many electron flow when current of, so this is current is equal to 5 ampere is passed through time t is equal to 200 seconds. So how many electrons is passed? So first we have to calculate the mole. So what is the how many moles of electrons? So moles of electrons is equal to current in ampere into time in seconds, this whole divided by 96500 and multiply by 6.022 into 10 to power 23. Then if you substitute this value, how many electrons are involved? How many electrons are involved in the reaction when 0.40 Faraday of electricity is passed through an electrolytic solution? How many electrons? So this is electrons. This is Faraday passed through electrolytic solution. So this is very simple. 0.4 multiplied by 6.022 into 10 to power 23. So we'll get the answer. Faraday multiply the mole. So this is Faraday. Faraday multiplies the mole. This is mole actually. This is Faraday and this is mole. 1 mole. So this is 1 mole. This is Faraday. If you multiply Faraday with the number of moles of electron, Avogadro number, will get the moles of electrons. A solution of copper sulfate is electrolyte using current. So this is current in ampere. This is time 10 minutes, 10 multiplied by 60, will get the seconds. Mass of copper deposited. So mass of copper deposited is equal to current in ampere into time in seconds. This whole divided by 96500 coulombs multiplied by mole ratio and multiply by molar mass. So what is the number here? So number here, current in ampere how much? 1.5 multiply by time how much? 10 into 60. This whole divided by 96500 multiply by mole ratio copper 1/2 multiply by molar mass 63.7. So we'll get the answer 0.297. 0.297. Number of electrons involved in the reaction when 1 Faraday of electricity is passed an electrolytic solution. So this is 1 Faraday. 1 Faraday is equal to Avogadro number 6.022 into 10 to power 23. 1 Faraday is equal to 1 mole of electron. 1 mole electrons. So 1 Faraday is equal to 1 mole electron. And what is the 1 mole of electron? Is equal to Avogadro number. How many Faradays of electricity required to produce 4.8 gram magnesium cathode? So this is the 24. So this is mole. The first we have to calculate the mole. What is the mole? Mole is equal to 4.8 divided by 24. So this is how much? This is 0.2 mole. Then magnesium chloride has a 2 moles. So this is the for 1 mole. That's how many Faradays of electricity required. Moles and Faradays are equal. So Faradays are equal to Faradays is equal to, that's the mole ratio. So what is the mole ratio? Mole ratio is equal to 1/2. Mole ratio multiply by mole ratio 1/2 is equal to moles of electrons. So what is the mole ratio? 1/2 किंवा आपण नंबर घेऊ शकता तुम्ही. Faraday directly calculate करता तो Faraday according to reaction. So Mg gives Mg2 plus 2 electron, 2 gives Mg. So this is the 0.2. 1 mole, 2 mole electron. So 0.2 mole is equal to 0.4 mole electron. So 0.4 Faraday. This is 0.4 mole electron. Faraday and mole both are equal. What is the SI unit of electrochemical equivalent? Kilogram per coulomb. Kilogram per coulomb. Mass divided by charge. Which from following is not correct? Is not correct regarding electrolysis. It helps in refining of metal, correct. Conversion of electrical energy into chemical takes place. It is useful in electroplating. Metal is deposited at anode. This is not correct. Metal is deposited at cathode due to reduction. Question 2021. Level change झाले question ची level. Easy question. How many faradays of electricity is required to produce 10 gram calcium? So 10 gram calcium, molar mass 40. So what is the mole? First we have to calculate the mole. Mole is equal to 10 by 40. So 1 by 4 is equal to 0.25. So 1 mole calcium, that's a 0.5 Faraday. 0.5 Faraday of calcium. Okay, for 2 mole calcium, 1 Faraday. What is the number of electrons passed through electrolytic solution when current of ampere? So current ampere 1, this is time 16.1 multiplied by 60 seconds. It should be second. And so this is the number of electrons. So how to calculate? So number of electrons is equal to current in ampere into time in seconds, this whole divided by 96500, and this whole multiplied by 6.022 10 to power 23 Avogadro number, multiply by Avogadro number. So substitute all these values, we will get the answer 6.022 into 10 to power 21. During the electrolysis of fused NaCl, the product obtained at anode chlorine. So many times, same question. Chlorine obtained at anode. What is the weight of aluminum deposited at cathode when current of? So this is the current 1 ampere. This is seconds, so time t. And what is the weight? So what is the formula here? W is equal to current in ampere into time in seconds, this whole divided by 96500 multiply by mole ratio how much? Aluminum 31 ratio 1 by 3 multiply by molar mass 27. So if you solve this question, we'll get the answer. So this is current in ampere, time in second 96500. So this is 1 ampere multiplied by 9650. Get cancel, we get the answer 0.9. Please check kara, 0.9 is your answer. Current in ampere, time in seconds, divided by 96500. Multiply by mole ratio into molar mass. Molar mass is the 27. What is the number of moles of electron passed through when current? Same question, current 5 ampere, time 20 minutes. So this is 20 multiplied by 60 seconds, number of moles. So number of moles is equal to how much? Current in ampere, how much? 5 ampere multiplied by time in seconds, so 20 multiplied by 60. This whole divided by 96500 coulombs. So if you solve this, we'll get the answer 6.25 into 10 to power minus 2. I am writing direct value. The direct value as a formula, current in ampere multiplied by time in second divided by 96500 coulombs. We'll get the number of moles of electron pass. If Q is the charge of 1 mole of electron equal to 96500 coulomb, then number of moles of electron actually pass. It's very easy. Q divided by 96500. How many coulombs of electricity required to deposit? So coulombs which are at, this is the 1 gram, W is equal to 1 gram calcium from calcium ions. So how many coulombs of electricity? 1 gram. So mole, okay, we have to calculate a mole. Mole is equal to 1 by 40. So 1 by 40 is equal to 0.25. So 0.025. Okay, 0.025. This is mole. Get it? So 1 mole 96500 coulomb. 1 mole is equal to 96500 coulombs. So how much required for the 0.025 mole? .05 Faraday electricity is passed through. So this is Faraday. Calculate the mass of copper deposited at cathode. So this is the mass of electricity. So what is the mass of electricity? 0.05 Faraday. So okay, what is the coulomb here? So this is the mass of the copper, W of copper is equal to 0.05 multiplied by 96500 coulombs divided by 96500 multiplied by, what is the mole ratio of copper? 1 by 2. What is the molar mass? 63.5. Okay, then 96500 get cancelled. If you solve this, you will get the answer 1.59. Faraday. First we have to convert the Faraday into coulomb. How to convert Faraday ampere? 2 multiplied by time in seconds. So this is 30 multiplied by 60. This whole divided by 96500 and this multiplied by, what is the mole ratio of the chlorine gas? So chlorine is the 1 by 2 multiplied by, and that's a chlorine 35.5. If you take the 35.5, so taken as a 1 by 1 and this is 35.5. Then if you solve this, all this will get the 1.32. So what is the formula? So formula is that, I am showing here. What is the formula? So formula is that, this is the formula actually. Current in ampere, time in second, 96500, mole ratio multiplied by molar mass of product. Okay, get it? This is the formula actually. Mass of product formed, current in ampere, time in second, 9650 multiplied by mole ratio multiplied by molar mass of product. Okay, next question. How many moles of electron required to reduce 1 mole nitrate to ammonia? So what is the oxidation state of nitrogen here? Oxygen, okay, nitrogen -2. So this is the -6. So this is -6 is equal to -1. So this is the x value. So how much x value? X is equal to +5. So this is +5. So +5 into hydrogen +3. So this is -3. So nitrogen +5 convert into nitrogen. How much nitrogen? -3. So how many electrons added? 8 electrons. I think this is the 8 electrons. 8 electron. So this is the 8 mole electrons. This is 1 mole. This is 8 mole electrons. Okay, get it even? Just calculate the oxidation state. By calculating oxidation state of nitrogen, ची oxidation state calculate करा. Nitrogen +5 to -3 है. So this is the 8 mole electrons. So 8 mole is the, okay, this is your answer actually. 8 mole electron. This is a very, very important question. How many faradays of electricity is required to produce 18.7 gram Fe, molar mass Fe, so this is mole. So first we have to calculate the moles. 18.7 divided by 56. And so 1 mole required. 1 mole required 3 Faradays. Fe3 na. So 1 mole required 3 Faradays. So this is the 0.3 Faraday actually. This is the answer as a 1 by 3 na. So this is the 1 by 3. 0.33. Okay. So this is 0.3. So 0.3 required. 0.3 mole required question mark. Okay. So this is 1 mole. What current strength is required to deposit 36 gram of silver? So 36 grams silver in 7 minutes for AgN of the solution by electrolysis. So this is the current in ampere. Current in ampere we have to calculate it. This is the W we have to given. Time is given 7 multiplied by 60 seconds. And this is atomic mass is the molar mass. So what is the formula? W is equal to weight of the substance deposited liberated. So this is the formula actually. This is the formula. Ha formula वापरायचा. W is equal to current in ampere into time in second 9650 mole ratio molar mass. Okay, I am just substituting the value in formula. 36 is equal to current in ampere we have to calculate it. Multiply by time in second how much? 7 multiplied by 60. This whole divided by 96500. This whole multiply by mole ratio silver 1 by 1. Multiply by atomic 108. If you solve this, we'll get the answer 76.6 ampere. Just cross multiply. By using the formula, this is your formula actually. Mass of product is equal to current in ampere, time in second divided by 96500 multiplied by mole ratio multiplied by molar mass of product. Okay, all these formula are very, very important. Always remember. All formulas Q divided by 96500 multiplied by mole ratio, current in ampere, time in second, divided by 96500 multiplied by mole ratio. I am using all this formula here. Mole ratio, how to calculate the mole ratio? Mole ratio, moles of product formed in the half reaction divided by the moles of electrons required. Okay, get it even? So all these are the formulas we have to use in this session. Moles of product form, mole ratio. Okay, get it? Okay, now start the next question. How many moles of electron required for the reduction of 1 mole Cr3 plus? So this is the Cr3 plus 3 electrons to give the Cr. So this is the 3 mole. This is your answer. 3 moles electrons. Next, okay, calculate the quantity of electricity required to produce. So again the formula is 4.2 is equal to cathode during electrolysis of silver nitrate. So how much coulomb we have to calculate it? So this is the coulomb divided by 96500 multiply by mole ratio 1 by 1 multiply by molar ratio 108. Okay, if you solve this, we'll get the answer 375. Okay, this is the formula. The हा formula है. Get it everyone? Current in ampere, time in second is coulombs, na? Current in ampere into time in seconds. This is whole called as a coulomb. So this is the coulomb. Mole ratio we have to calculate it. Silver as a mole ratio 1 by 1. How many coulombs of electricity required to produce? Same formula, I think. Same formula we have to use. So this is 1 gram. This is 1 is equal to coulombs divided by 96500 multiply by sodium mole ratio 1 by 1 multiply by 23. If you solve this, we'll get the answer 4196. Are you getting? Question number 36, same formula. Coulombs divided by 96500 multiply by mole ratio multiply by molar mass. I am using this formula. Current in ampere into time in second, together called as the coulombs. Next question. Calculate the mass of divalent metal produced at cathode by passing the 5 ampere current through its salt solution for 100 minutes. Molar mass X. Same question. Mass of divalent metal A, mole ratio 1 by 2A. So what is the formula here? Calculate the mass of the divalent atom. So W we have to calculate it. W is equal to the current in that. So this is the 5 ampere current. So 5 multiplied by this is 100 multiplied by 60 because this is the current in ampere and this is the time is equal to this is minute multiplied by 60, so we'll get the seconds divided by 96500 multiply by divalent A 1 by 2 है mole ratio 1 by 2 multiply by molar mass X value put करा solve करा. This is 30 divided by 193. 30 divided by 193 multiply by X. I am using this formula here. This is the formula. Current in ampere, time in second, 96500. Mole ratio is the 1 by 2 because divalent. Molar mass taken as the X value. Molar mass taken as the X value. Okay, are you getting this one? Question number 37. W is equal to current in ampere, time in second, 100 minute is the 100 multiplied by 60 divided by 96500 coulomb. Divalent stand for mole ratio 1 by 2 and molar mass taken as the X value. So this is the formula. Okay, next question. Identify the reaction taking place at anode during electrolysis of molten NaCl. So molten NaCl at the anode oxidation reaction. So at anode oxidation reaction. So this is oxidation. Simple question. How many moles of electrons are required for reduction of 3 moles of zinc to Zn2 plus? So this is the Zn2 plus 2 electron to give the zinc. So this is the 1 mole. This is 1 mole. 1 mole required 2 mole electrons. So 2 mole electrons. And if you take the 3 moles, this is 3 mole. 3 mole. So this is your answer 6. For 1 mole zinc, 2 mole electron required. For 3 mole zinc, 6 mole of electrons will require. Next question. What will be the weight of aluminum deposited Faradays of electricity pass through aqueous solution AlCl3? So this is the Faradays of electricity. So W is equal to what we have to calculate? Okay, calculated 0.5. So this is 0.5 Faradays. That is the mole multiply by mole ratio. What is the mole ratio? 1/3, and multiply by the molar mass 27. So we'll get the answer 4.5. I am using the formula. This is the formula actually. Mole ratio. Moles of product form. Moles of product form. So this is actually called as the okay, next question. In a certain electrolysis experiment, 0.6 gram of zinc is deposited. So this is the zinc deposited in zinc half cell solution. Copper deposited with the another copper sulfate solution. So what we have to use here? So by using the two different electrolytic solution. So if you use this formula, this is the formula actually. Weight of that's a substance deposited divided by the W. This is the formula. So W1 divided by W2 is equal to mole ratio of 1 multiplied by M1. This whole ratio divided by mole ratio of 2 multiplied by M2. Get it? Mole ratio 1 multiplied by molar mass. So this is the zinc. So calculate the mass of copper. So this is the mass of copper divided by mass of zinc is equal to what is the molar ratio of copper? Copper as the 1/2 divided by zinc mole ratio 1/2 multiply by what is the molar mass? Molar mass of copper 63.5 divided by molar mass of zinc 65. So this is 1/2 get cancelled, and so mass of the copper. So this is the mass of the copper. Mass of copper deposited is equal to 1/2 get cancelled. So this is the weight of zinc multiplied by 63.5 divided by 65. So weight of zinc, how much weight of zinc? 0.6. So 0.650 and multiply by 63.5 divided by 65. If you solve this, we'll get the answer 0.635. I am using the formula. So this is the formula. Weight of copper deposited divided by mole ratio of copper multiplied by the molar mass of copper. Okay, this is the formula actually. And this is the formula actually. Here it is written as the one of the problem. Okay, get it everyone. Next question. How many Faradays of electricity required to produce 5 gram of magnesium from magnesium chloride? So 5 gram magnesium from magnesium chloride. How many Faradays of electricity required? So this is the 5 gram. So this is the mole. First we have to calculate the mole. Mole is equal to how much? 5 divided by 24. 5 divided by 24 mole. And 1 mole required 2 Faraday. So 5 by 24 required how much? 0.415, okay, 0.417 Faradays. So this is the mole, 5 divided by 25. 1 by 5 kara, 1 by 5. So 1 by 5 how much? Magnesium, 1 mole magnesium required 2 Faradays. How long will it take to produce? How long? So we have to calculate the time, question mark, time. So this is W value, W 5.4 gram. AgCl, silver chloride, 5 ampere current. So this is current and molar mass. So what we have to write here? W is equal to, so W 5.4 is equal to current in ampere. What is the current in ampere? 5 multiply by time in seconds, divided by 96500 coulomb, multiply by silver mole ratio 1 by 1, multiply by molar mass 108. If you solve this for t is the time, so 965 second is your answer. I am using the formula. This is the formula we have to use here. This is the formula, mass of product form. Okay, get it? How many Faradays of electricity required to produce 40 gram aluminium? So 40 gram aluminium, and this is the molar mass. So mole is equal to 40 divided by 27. First calculate the mole, and then Al2O3. Al2O3 plus 3. So 1 mole required. Okay, 3 Faradays of electricity. 3 Faradays. So 40 divided by 27 mole calculate kara, and then we'll get the answer 4.4. 4.4 Farad. During electrolysis, 2 ampere current is passed through, divided by 96500. If you solve this, you will get the answer 0.02. I am using the formula. This is the formula here. Moles of electron actually pass. Moles of product form. Moles of electrons actually pass. Where it is the formula? Moles. Mole ratio. Moles of electrons actually pass. Coulombs. So coulomb. What do you mean by coulomb? Current in ampere, time in second. Coulomb. Q is equal to current in ampere. 60 seconds. So what is the mass of copper? So W of copper is equal to current in ampere 2.5 multiplied by time 40 multiplied by 60, and this whole divided by 96500 multiplied by mole ratio. What is the mole ratio of copper? 1 by 2 multiplied by what is the molar mass? 63.5. Okay. How many Faradays? So what is your answer? Answer as the 1.9. 1.974. 1.974 gram. How many Faradays of electricity required to liberate? 12 gram. hydrogen during electrolysis of aqueous NaCl solution. How many Faradays? So how to calculate the Faradays? Hydrogen during electrolysis of aqueous NaCl. Aqueous NaCl 12 gram 12 Faraday. 12 gram is equal to 12 Faraday. Okay, for hydrogen. How many moles of copper are produced by passage of current in ampere, time in seconds? So this is current in ampere. I is equal to time t is equal to 100 multiplied by 60 seconds. Molar mass is given. So how many moles of copper deposited? So moles of copper is equal to current in ampere 5 multiplied by 100 into 60, this whole divided by 96500. So if you solve this one, we'll get the answer 0.1554. I am using the formula. This is the formula. Moles of electron actually pass. Moles of electrons actually pass. किंवा moles of product actually form. Moles of product form. Moles of electron actually pass multiply by mole ratio. Moles of copper form. And multiply by the mole ratio. So what is the mole ratio here? Mole ratio of copper 1/2. Copper चा mole ratio 1/2 है. Identify the reaction that takes place at cathode. At the cathode. Molten NaCl. Molten NaCl, Na plus 1 electron to give the Na. So this is reduction. At cathode, reduction takes place. And this is at anode. This is at anode. Oxidation takes place. Oxidation takes place. What current strength in ampere? So this is the current in ampere. We have to calculate the current in ampere. Required to produce. This is kilogram as a gram. From copper sulfate 1 hour. So T is equal to 1 into 60 seconds. Molar mass is given. Current strength. So what is the formula? 2.37 mass of copper deposited is equal to, what is the current in ampere? So we have to calculate current in ampere into time in second. How much? 60 multiplied by 60. This whole divided by 96500 multiplied by mole ratio. What is the mole ratio? Copper 1/2 multiplied by molar mass 63.5. Then if you solve this, we'll get the answer 0.2. 2.0 is your answer. Please check. And this is the formula we have to use here. What is the formula? Mass of product is equal to current in ampere, time in second divided by 96500 coulomb per mole. Mole ratio, molar mass. Next, calculate the mass of chlorine gas. So mass of chlorine gas, W we have to calculate it. Molar mass, 1 current is equal to 1 ampere and time is equal to 965 seconds. Okay. So what is the formula? W is equal to, so okay, what we have to calculate it? Weight of chlorine. So W we have to calculate it. Current in ampere is the 1 ampere, time in second 965. This whole divided by 96500 coulombs multiply by mole ratio chlorine as the 1/2 multiply by molar mass 71. If you solve this, we'll get the answer W. So W as answer 0.355 gram. सेवन्टी वन डिवाइडेड बाई 2 35 and 35 चा पॉइंट शिफ्ट करून घ्या 965 get cancel 10 to power minus 2 so 10 to power minus 2 become as a 0.355 okay get it I am using the formula this is your formula mass of product is equal to current in ampere highest very good option number 3 is correct mass of product form mass of the product form is equal to moles of product multiply by molar mass of product okay next question what quantity of electricity required for reduction of 3 mole aluminum to aluminum very easy question aluminum as Al 3 plus 3 electron 2 gives the Al so this is 1 mole 3 Faraday 3 mole 3 Faraday so this is 3 mole if it's 3 mole this is how much 9 Faraday so 9 Faraday is your answer okay are you getting this one 3 mole Al3 plus 3 mole next question how many Faradays of electricity required to produce 20 gram calcium from molten calcium chloride molar mass is given so okay first we have to calculate the mole so mole is equal to 20 divided by 40 calcium na so this is 20 divided by 40 0 get cancel 1 by 2 is a 0.5 get it so 1 Faraday is your answer 1 Faraday because calcium so calcium 2 plus 2 electron so 2 gives a calcium so 1 mole calcium required 2 Faraday so my question is that 0.5 mole calcium required how many Faradays question mark so 1 mole required 2 Faraday 0.5 mole required 1 Faraday so simple how to convert the mole mass divided by molar mass divided by molar mass so calcium has a 40 mass calcium 20 by 40 what are the different gases evolved at the anode and cathode electrolysis of aqueous NaCl so chlorine and hydrogen aqueous NaCl chlorine and hydrogen which of the following is not true about electrolytic cell not true about electrolytic cell it convert electrical energy into chemical correct है anode cathode acts as positive बरोबर है cathode negative है correct it used for generation of electricity no it is not correct this is for galvanic cell this is for galvanic it is generation of electricity it is galvanic or voltaic cell calculate the mass of silver deposited this is the coulombs so directly coulombs coulombs AgNO3 mole ratio 1 by 1 molar mass is given so W is equal to what is the W is equal to 96.5 divided by 96500 multiply by mole ratio silver 1 by 1 multiply by 108 and if you solve this, we'll get the answer 108 milligram, but this is milligram. This is 108 into 10 to power minus 3 gram. So milligram convert into gram. So please solve this, we'll get the answer. Please check करा problem number 56. Are you getting milligram? Milligram is your option, but milligram is the 10 to power minus 3 gram. I am using the formula. So current in ampere, time in second, all together given as a coulombs. Current in ampere, time in seconds, all this together as a coulombs. Coulomb divided by 96500 multiply by mole ratio multiply by molar mass. Get it? Very, very important, CET 2023. Okay, now start the next question. What mass of aluminum deposited at cathode during passage? Same question, same. Current in ampere, time 50 minutes से 50 multiply by 60 seconds करूँगा, seconds. आणि molar mass. So what is the formula here? W is equal to current in ampere 5 multiply by time 50 multiply by 60. This whole divided by how much? 96500 multiply by mole ratio 1 by 3. Aluminum mole ratio 1 by 3 and molar mass 27. If you solve this, we'll get the answer 1.4. Calculation become fast and accurate. Always remember, if you calculate the fast and accurate, we'll get the maximum chance to solve all the questions 50 by 50 in chemistry. Get it? Again, I am using the same formula here. Current in ampere, time in second, 9650, mole ratio, molar mass. Mole ratio aluminum 1 by 3. Calculate the mass of cadmium deposited. Cadmium, copper deposited, copper, definite quantity. Copper cadmium. So this is very easy question. Again, that's a two different shell. So this is the that's a copper deposited, copper quantity. Calculate the mass of cadmium. So W of cadmium. So W of cadmium we have to calculate it, and W of the copper. So copper is a 6.35. So is equal to, so mole ratio of the cadmium. So cadmium mole ratio 1 by 2, copper mole ratio 1 by 2 multiply by cadmium molar mass 112 and multiply by copper 63.5. So this is 1 by 2 get cancelled. So weight of cadmium deposited is equal to 1 by 2 get cancelled. Huh? So this is 112 multiply by 6.35 and this whole divided by 63.5. So we'll get the answer 11.2. I am using the formula when the two different electrolytic cells are used in series. So this is the formula actually. This is the formula. Weight of one cell is equal to the mole ratio of 1 multiplied by M1. Okay, this is the formula. I am using the formula weight of copper, weight of one cell divided by mole ratio of 1 multiplied by molar mass of 1 is equal to weight W2 divided by mole ratio 2 multiplied by molar mass of second. So this is actually your formula. Weight of cadmium divided by the weight of zinc, weight of cadmium divided by weight of copper is equal to mole ratio multiplied by molar mass, mole ratio multiplied by molar mass. Just substitute the value. Okay, reorganize 6.35, 33.5, point shift करा 1/10 है. 6.35 divided by 63.5, this is 1/10th, 1/10th. So 112/10th is the 11.2. Okay, next question. What volume of chlorine gas molar mass? Volume विचारलाय. Chlorine gas is produced at STP by passing 2 ampere current through fused NaCl. Second, and at STP volume 22.4 dm cube. So at the end we have to use the relation. So first convert the weight. So W is equal to W we have to calculate it for chlorine. So what is this? This is the current in ampere. 2 ampere current hai. This is time in seconds hai. So this is the current in ampere. 2 ampere multiplied by 482.5 seconds. This whole divided by 96500 multiply by mole ratio chlorine 1/2 multiply by molar mass 71. So we'll get the W weight and mass divided by, and this whole term divided by 22.414 will get the volume liters. So 1 mole mass calculate होईल ना, mass वरून volume calculate करावं लागेल. ठीक आहे. So by using this formula we have to calculate the weight. Get it? Weight calculate करा. आणि weight calculate झाल्यानंतर तर 1 mole is equal to 71 gram. So this is the how much weight. The weight बरोबर mole ला compare करा. Get it? Okay, compare into mole, and so that's 1 mole is equal to 22.4 dm cube. So what is the dm cube? Dm cube is equal to 22.4 into 10 to power 3 centimeter cube. This is for 1 mole, and then compare for 1 mole. Okay, first we have to calculate the mole. Get it? Mole. And if you not want to calculate the mole, then just एवढं जरी calculation केलं तरी तुम्हाला डायरेक्ट मोल मिळते. दिस इज मोल ॲक्च्युअली. पहा लक्षात आहे, एवढं जरी कॅल्क्युलेशन केलं तर डायरेक्ट मोल कॅल्क्युलेट होतात. मोल्स ऑफ प्रोडक्ट फॉर मोल, इथून डायरेक्ट मोल कॅल्क्युलेट होतील. आणि मोलला जर का ह्या नंबरने तुम्ही डिवाइड केलं, मल्टिप्लाय करून घेतलं 20.4 इंटू 10 टू पॉवर 3, डायरेक्ट आन्सर भेटेल. डायरेक्ट 112 सेंटीमीटर क्यूब. Okay. Next question. Okay, what is the time in seconds? So T is equal to, we have to calculate it. T is seconds. Gram iodine. So this is W. W we have to calculate. W given and time we have to calculate it. Second. KI solution है. Electrolytic using current in ampere दिला है आणि iodine दिला है 127. So what is the formula we have to use here? W iodine, how much? Iodine is given as a 12.7. So 12.7 is equal to, so current in ampere. So what is the current in ampere? 4 ampere multiplied by time in seconds. This whole divided by 96500 coulombs multiplied by mole ratio. Iodine has a mole ratio. Iodine has a mole ratio 1/1 multiplied by molar mass 127. Okay, if you solve this, we'll get the answer 2412.5. I am using the formula. This is the formula here. Mass of product form is equal to current in ampere, time in second divided by 9650 coulomb multiplied by mole ratio multiplied by molar mass. Mole ratio iodine 1/1. Okay. Next question, which of the following is correctly defined electrolysis process? Which of the following represent the electrolysis process? Breaking down of an ionic solid compound by adding solvent? No. Breaking down of covalent solid compound? No. Breaking down of ionic compound molten state or aqueous state by passing electricity? Yes, it is correct. Breaking down of covalent bond aqueous solution? No. How many moles of electron required to produce gram silver A? Molten mass A. So what is the formula here? So formula as a moles of electron, mole of electrons is equal to so simple here mass दिलाय तुम्हाला. So moles of electrons required. So this is mole. Mole we have to calculate it. Mole is equal to 10.8 divided by 108. So this is equal to 0.1. 0.1. And so silver as the Ag1 plus electron 2 gives the Ag. Okay. So this is 1 mole silver metal from salt solution. So this is 1 mole required 1 Faraday. This is the 1 mole electron. 1 mole electron. So this is 0.1 mole required. How much? So this is 0.1. Find the number of moles of electron required to produce. Again the 5 mole. Same question here. Zn2 plus 2 electron 2 gives the Zn plus 2 electron 2 gives the Zn zinc. So this is the 1 mole. This is the 1 mole. 1 mole zinc required 2 mole electron. 2 mole electron. So 5 mole. This is 5 mole. So 5 mole required how much? 5 mole zinc. So this is 5 mole actually. 5 mole zinc required how much mole electron? So here as a question mark. So 10 is your answer. 10. 1 mole required 2 mole electron. 1 mole zinc required 2 mole electron. So 5 mole zinc required 10 mole electrons. Next, calculate the current in ampere required to deposit. Current in ampere required to deposit. W is given. Time T is equal to 30 minutes. So 30 multiplied by 60 is seconds. So W is equal to W 4.8. 4.8 is equal to current in ampere. So this is the current in ampere. We have to calculate it here. Multiply by time in second. 30 multiplied by 60. This whole divided by 96500 multiply by mole ratio copper 1/2 multiply by molar mass 63.5. If you solve all this, we'll get the answer 8.1. And I'm using the formula. This is your formula. A mass of product is equal to current in ampere time is second divided by 96500 coulombs multiply by mole ratio multiply by molar mass of product. Okay, get it even. What mass of magnesium is produced during electrolysis of molten MgCl2? Molten MgCl2 by passing 2 ampere current for. So what mass of magnesium? So W we have to calculate it. MgCl2 current in ampere. So what is the current 2 ampere? Time T is equal to given. And so what is the W formula? So W is equal to current in ampere 2, time in seconds 482.5. This whole divided by 96500 multiply by magnesium mole ratio 1/2 multiply by molar mass 24. If you solve, you'll get the answer 0.12 gram. Next question, the number of faradays of electricity required to produce 45 gram of aluminium molten Al2O3. Number of moles of faradays electricity 45 gram. So this is mole is equal to 45 divided by 27. Mass divided by molar mass aluminium. And then solve kara. So 1 mole required. So this is mole. Mole we have to calculate it. And 1 mole required. 1 mole aluminium or required 3 mole electrons. So this is 3 Faraday is equal to 3 Faraday. So how much mole? Okay, that's 45 divided by 27. Okay, 5 Faradays. A electrolytic cell containing zinc, aluminium, same question here, containing series W. If the 6.5 gram zinc is deposited, one cell calculate the mass of aluminium. So mass of aluminium, W of aluminium divided by W of zinc is equal to, what is the mole ratio of aluminium? Is 1/3 multiplied by aluminium molar mass 27, zinc 1/2 multiplied by zinc 65, and then that's the W of zinc. So W of Al aluminium is equal to weight of zinc. So weight of zinc, weight of zinc is given. What is the weight of zinc? 6.5 gram. So 6.5 multiply by how much? 6.5 multiply by 1/3 multiply by 27 multiply by 2 multiply by 2 and then divide by 65. Okay, if you solve all this, we'll get the answer 1.8 gram. Okay, Okay, next question. Calculate the time required in second to deposit. So T is equal to question mark. W is equal to 6.35. Current in ampere 5 ampere, and so molar mass. So what is the formula here? W, what is the W given? 6.35. So 6.35 is equal to current in ampere. So what is the current in ampere? 5 multiply by time in seconds divided by 96500 multiply by mole ratio 1 by 2 multiply by molar mass 63.5. Okay, then multiply and then divide, we'll get the answer 3860. I am using the formula. This is your formula. Mass of product, current in ampere, time in second divided by 96500 coulomb, mole ratio multiplied by molar mass. Very, very important formula. Next question. What is the number of moles of electron required gained by 1 mole of oxidizing agent in following redox reaction? So first find out the oxidizing agent here. So this is 0, this is Zn2 plus. So oxidation take place reducing. So this is actually oxidation होता है, हा reducing आहे आणि oxidizing विचारलंय. So HCl बद्दल विचारलंय. Okay, HCl. So this is plus 1 and this is 0. So hydrogen. So hydrogen बद्दल विचारलंय. 1 mole oxidizing agent. 1 mole hydrolyzing agent. So this is the H plus plus 1 electron, 2 gives H. Okay, number of moles of electrons. Hydrogen, 1 mole oxidizing agent. One mole oxidizing agent, yes, 1 mole. This is 1 mole. 1 mole electron. So plus 1 to 0. This is reduction. And this is oxidizing agent. Because they undergo reduction. Process has a reduction. Oxidizing agent itself undergo reduction. So hydrogen 1H plus. What is the quantity of density required to liberate? Coulombs मध्ये a centimeter cube of hydrogen gas at STP from acidified water. So this is 112 centimeter cube hydrogen gas. So this is first convert the mole. So mole is equal to 112 10 to power minus 3 liter divided by 22.414 liter. So is equal to 0.01 mole. Okay, like chlorine है ना. So this is the hydrogen has H2. So hydrogen has a H2. So this is how much value here? 1 by 2. So this is point shift करूँगा. How much? 1 by 2. And 10 to power minus 3. So 965 coulomb is your answer. 965 coulombs. Acidified water, hydrogen gas. So hydrogen gas how much? Twice H plus 2 electron, 2 gives the H2 gas. Hydrogen gas. So as the hydrogen gas is 112 into 10 to power minus 3 liter, first we have to convert the mole, and then 1 mole is equal to, using the relation, 1 mole is equal to 96500 coulombs. 96500 coulombs. So actually this is the 0.01 mole. So is equal to 965, only 965 coulomb. Okay, get it? Next, okay, calculate the number of moles of electron required to convert 1.1 mole. Very important question. Okay, what is the oxidation state here? Number of moles of electrons. CR oxidation state. How much? This is minus 14 plus 14, 12 plus 6. So this is plus 6. So chromium plus 6 plus 3 electrons plus chromium plus 6. 2 times chromium plus 6. Okay. Chromium plus 6. 2 mole. And this is how much? 3 electrons. 2 gives chromium 3 plus. Okay. So if this is 2 mole, 3 mole electrons. So if this is the 1.1 mole, 1.1 mole. So what is your answer? So this is a chromium adds a plus 6, 3 mole electron. So it should be equal to 6.6 mole electrons. (1.1 mole Cr2 2 times chromium. So multiply by the 2 times. 2 times chromium. Cr2O7 2 minus. Next, calculate the number of moles of electron required to convert 0.08 mole of MnO4 minus. So MnO4 minus, so plus 7. Plus 7 to plus 2. So Mn plus 7 plus how much? 5 electrons. 2 gives Mn plus 2. So this is 1 mole. 0.08 mole. So this is 1 mole. 1 mole required 5 mole electrons. And if 0.08 mole, then how much will be required? So 0.08 multiplied by 5 divided by 1 is equal to 0.4. So 0.4 is your answer. Please check our question number 72. Everyone get it? Calculate the number of moles of electron required to convert 0.08 mole of MnO4 minus. So oxidation state Mn plus 7. 2 Mn2 plus. So Mn plus 2 is the oxidation state plus 2, directly plus 2. So plus 7 to plus 2, so 5 electrons should be added. So 1 mole Mn plus 7 required 5 mole electron. So okay, question as a 0.08 mole of MnO4 minus required how much mole electron? So it should be 0.08 multiplied by 5 divided by 1 will get the 0.4. Very important question. Please IMP करा question 2026 CET साठी. Next question. Calculate the number of moles of electrons required. 0.1 mole zinc. So zinc Zn2 plus 2 electrons. 2 gives zinc. So 1 mole required 2 mole electrons. So my question is that 0.1 mole required how much mole of electrons? So solve in this way. 0.1 multiplied by 2 divided by 1 is equal to 0.2. So 0.2 is your answer. Okay, get it? Okay, what current strength in ampere? So current in ampere is equal to question mark. This is the coulombs. So coulombs is equal to that's a time. T is equal to how much? 7 minutes. 7 multiplied by 60 seconds. So what is the formula? Coulombs is equal to current in ampere multiplied by time in seconds. So what is the coulomb? So what is the current? Current in ampere, I is equal to coulombs divided by time in seconds. So what is the coulombs? Coulombs is given as 850 divided by time how much? 7 multiplied by 60. So if you solve this is the 2. So 2 ampere is the current. Question 2024 है. CET 2024. Very easy question. 0 get cancel. First 0 get cancel. 7 6 56. 85 divided by 56 is the 2 times. This is 85 divided by 7 into 6. So 85 divided by 56. So 56 80 by, so this is 2 actually. $42 करा 42. Okay. In the electrolysis of HENO3 solution, 108 gram silver is deposited at the cathode. Calculate the quantity of electricity required in coulombs. This is the W actually. W we have to given here. Quantity of electricity required in coulombs. Molar mass is given. Okay. Coulombs. So how much coulombs we have to calculate it here? So W how much given? 108 is equal to coulombs. Coulombs we have to calculate it, divided by 96500 multiply by silver mole ratio 1/1 multiply by molar mass 108. If you substitute all this value, then calculate it. 965 coulombs is your answer. I am using the formula. This is the formula. Current in ampere, time in second, all together as the coulombs. Current in ampere, time in second, all together coulomb. Coulomb divided by 96500 multiply by mole ratio multiply by molar mass. So this is your answer. Calculate the amount of electricity required in coulomb to convert 0.0. Same question, same. Okay, so this is the +7 here, +7 +2. So Mn +7 +5 electrons, 2 gives Mn +2. Okay, so my question is that, so this is the 1 mole. 1 mole required 5 mole electrons. 5 mole electrons. So 0.08 mole required how much? So 0.08 multiplied by 5 divided by 1. So this is a 0.4 mole electron. So but 1 mole is equal to 96500 coulombs. So 0.4 mole is equal to 0.4 multiplied by 96500 coulombs. Okay, if you solve this, we'll get the answer 38,600 coulombs. Which of the following is released at cathode during electrolysis of aqueous hydrogen gas? If 5 ampere current flows through electrolytic solution, so current in ampere 5, this is time, number of moles of electron pass. So number of moles of electron is equal to current in ampere 5 multiplied by time in seconds 19300 divided by 96500 multiplied by mole ratio. Okay, what is the mole ratio? No need to apply the mole ratio. Directly solve the question. So 1. Next question 79. Which from following is not true about electrolysis of molten NaCl? Not true. Chlorine gas is liberated anode, correct. Sodium is deposited cathode, correct. The decomposition of NaCl into NaCl2 is spontaneous. It is non-spontaneous. This is not true because this is electrolytic process. Electrical energy is used to carry out the reaction, correct. Calculate the quantity of electricity required to produce 0.1 mole of chlorine gas. Mole दिलेला आहे. Sodium chloride, by using sodium chloride, chlorine gas है. So Cl minus gives Cl2 plus 2 electrons. So this is twice Cl minus. Okay. So 1 मोल क्लोरीन असेल, 1 मोल क्लोरीन, तर 2 फॅरेडे पाहिजे, 2 फॅरेडे. तर I have the 0.1 mole. So 0.2 Faraday. So 0.2 Faraday multiplied by 96500 coulombs. So this is your answer. Next, okay, same question. 1.1 mole Cr, so +6, and this is +3. So Cr +6 plus 3 electrons, 2 gives the Cr plus 3. Okay. So 1 mole required. So this is the 1 mole. Okay, if you apply this one, 1 mole required 3 faradays. So 1.1 mole required how much? 1.1 mole required 3.3 faradays. So therefore 3.3 faradays multiply by 96500 coulombs. So this is coulomb, and again this whole multiply by 2. This whole multiply by 2. We'll get the answer 6.369 into 10 to power 5 coulombs. What volume of the chlorine gas is evolved at STP during fuse initial current दिला है, current 1 ampere, time second से, volume 22 है. Same question repeated 2024. What is the quantity required to produce 4.8 gram magnesium? So mole convert करा, mole is equal to 4.8 divided by 24, okay, is equal to 0.2 mole. Get it? 0.2. So 0.4 farad is your answer. When fused NaCl undergo electrolysis, sodium is deposited at cathode. Sodium is deposited at cathode. Calculate the calcium deposited 0.8, current in ampere given a, time given a, t is equal to 60 multiplied by 30, 60 multiplied by 60 seconds. So what is the formula? W is equal to current in ampere 0.8 multiplied by 60 multiplied by 60, this whole divided by 96500 multiplied by mole ratio calcium 1/2 multiplied by molar mass 40. If you solve this, we'll get the answer 0.6 gram. I am using the formula. This is the formula. Moles of product, molar mass, mole ratio. Find the number of electrons that generate 1 coulomb charge. So 96500 coulomb, 96500 coulombs is equal to 6.022 into 10 to power 23. Okay. So 1 coulomb is equal to question mark. So 6.1 multiplied by 6.022 into 10 to power 23, and this whole divided by 96500. So we'll get the answer. So what is the answer? 6.24 into 10 to power 18. 6.04 into 10 to power 18 is the coulomb charge. So how much the number of electrons that generate 1 coulomb charge? So 1 coulomb charge is the 6.24 into 10 to power 18 electrons. This is actually electrons. Very important question. IMP kara, question number 86. What is the number of faradays required to produce 0.18 gram aluminium? So first convert into the molar mass. So this is the mole. So mole is equal to 0.18 divided by 27. And then 1 mole aluminium required required 3 Faradays. So how much mole will require this one? So 0.02. Next, calculate the number of electrons required to produce 0.1 mole aluminum from aluminum sulfate. 1 mole aluminum sulfate. So this is the Al3 plus 3 electron to give the Al. So 1 mole required 3 Faradays. Okay, 3 mole electrons. 3 mole electrons. So my question is that 0.1 mole is equal to question mark. So 0.1 as a 0.3 mole. But 0.3 how much? 0.3 mole multiply by 6.022 10 to power 23. Avogadro number. This is Avogadro number of electrons. What is the amount of aluminum deposited cathode? 1 Faraday. So Al 3 plus 3 electron to use Al. Okay. So 1 mole required 3 Faradays. So 1 Faraday is equal to how much? Question mark. 1 by 3, na? 1 by 3 is the 0.33. So this is 1 by 3. Which of the following statement is false about electrolysis? It is a non-spontaneous redox reaction. Correct है. Electrode connected to positive terminal battery acts as the anode. Correct. During electrolysis, chemical energy is converted into electrical. Chemical into electrical. No, this is not true. This is false. During electrolysis, anions of electrolyte are oxidized. Correct. What is the mole ratio of reaction? Cathode, copper. Copper is the mole ratio 1 by 2. So copper 2 plus 2 electron 2 gives copper. So mass of product form 1 divided by moles of electron 2. So mole ratio 1 by 2. Which of the following is cathode, electrolysis, aqueous solution, hydrogen gas? So simple question. What is the volume of hydrogen gas? Question repeat है 2024 मध्ये as it is question है 0.112 dm cube liter. As it is question 2024 repeated. Question number 94. Negative electrodes. Aqueous solution. Aqueous sodium chloride. Hydrogen gas is evolved. Reduction process. What current strength in ampere required to obtain? So this is ml. How much convert into liter? 1, 2, 3, 11.2 liter. So first convert as mole. So what is the mole here? Mole is equal to 11.2 liter divided by 22.414 liter. So how much? 1 by 2, 0.5. 0.5 mole. So 0.5 mole, what current strength we have to require here? So moles of product form is equal to current in ampere. So what is the current in ampere? Current in ampere into time in seconds. So what is the 96500 coulomb divided by 9650 divided by 96500 coulombs. If you solve, we'll get the answer 10. Okay, current in ampere. I am using the formula. This is the formula. Current in ampere. Okay. Hydrogen. Next, calculate the number of hydrogens. Calculate the number of the Faradays required to deposit. Faraday required to deposit. How much? 9. Okay, 6.35 gram copper aqueous solution. So this is very easy. So Farad is required. So W how much? 6.35. ठीक है. Directly पण solve होऊ शकतो. Mole calculate करा. Mole. First we have to calculate the mole here. And then compare the mole. So mole is equal to 6.35 divided by 63.5. So how much here? 0.1. 0.1 mole. Okay. What is the mass of hydrogen obtained at cathode during electrolysis of water by passing 4 mole electron from external source using inert electrode? Mass of hydrogen obtained at the electrolysis of water. So water gives H2 plus 1/2 O2. Okay. Mass of hydrogen. So what is the mass of hydrogen required? 4 mole electrons. So mass of hydrogen, W of hydrogen is equal to 4 moles of electrons into mole ratio of hydrogen. So 4 multiplied by mole ratio 1 by 1. So what is the answer? 4. So 4 gram. I am using the formula. Moles of electron actually pass. Moles of product form. Moles of electron actually pass. Multiply by mole ratio. So what is the time in seconds? So 100 multiplied by time in second divided by 96500 coulombs. Multiply by chlorine mole fraction of chlorine 1 by 2. So 965 second is your answer. If you solve this one, I am using the formula. This is your formula. Moles of product form is equal to coulombs divided by 96500 multiplied by mole ratio. Multiply by mole ratio. What is the number of Faradays required for 1 mole hydrogen by reduction of H plus? Repeat question 2024. Same question 2024. 1 mole hydrogen by reduction of H plus. H plus plus electron 2 gives H. So this is H2 twice H2 2 electron 2 mole electron 2 Faradays and 2 Faradays for 1 mole hydrogen. This is again the 1 mole hydrogen. So this is your answer, 2 Faradays. Okay, next question. What is the charge required to convert 2 mole KMnO4 plus 7? So plus 7 to plus 2. Plus 7 to plus 2. So therefore, Mn plus 7 plus 5 electron 2 gives Mn plus 2. So 1 mole required. So 1 mole required 5 mole electron. 5 mole electron. So 5 mole stand for 5 Faradays. This is for 1 mole.